Yeah, hi everyone, I'm Max. I'm CEO and co-founder of Silexica, and we heard many times like power, we heard like compute cluster, we heard, supercomputer, which is exactly what I'm going to talk about today. And I think for most, so one part of it is a hardware problem, but I think the answer at the end to the power problem is actually a software problem. So I apologize for talking a lot about software in a hardware meetup, but I think they're very much connected. So what you see here is actually a lot of different topics, a lot of promises, a lot of prototypes. No matter if you talk about self-driving cars, if you talk about 5G base stations, AR, AI, VR, lots of big promises. It's going to come really soon. We believe we're actually quite far away, and I want to go into some of the challenges why we think we're actually far away. So what they all have in common, they feature very intelligent applications, and what that means is you need all the processing capabilities, all the compute power you can actually get. And there was a lot of innovation in hardware, right? Obviously, PC era started, you go to your laptop, your mobile, ARMs and those kind of things. And now you have a lot of specialized, let's say, compute capabilities, right? There was a question earlier, do I need a GPU or an FPGA? I agree, everybody should know what an FPGA is, so we can talk about that later. So lots of different things. But the answer actually for autonomy, for example, self-driving cars, is actually you're going to have a mix of all those different chips on the same cluster, right? On the same supercomputer. So, I think nobody disagrees there that all future megatrends are going to be enabled by next generation supercomputing, by heterogeneous supercomputing, combining all those different technologies we saw on the previous slide actually in one big chip. And actually, if you talk to vendors, they think I need several of those chips, right? Whatever the latest, greatest platform out there is, it's not going to be good enough for level 5 really autonomous car. And everybody agrees with that, whoever you're talking to. But then, if you read some marketing stuff, it sounds like we're done. We're close and Waymo is driving around with his self-driving cars. But actually, if you open the trunk, you see something like this, right? Where certainly the power problem is not solved, but especially, one part of the key problem is like how to integrate it in a supercomputer in the middle of the car. That's certainly not solved. You have a bunch of applications running on very, very powerful supercomputers, but basically burning your trunk. So if you really want to talk about autonomous vehicles, certainly, there needs to be a huge amount of innovation, really driving that supercomputer from the trunk to your actual supercomputer in the middle of your car, right? So if you look into the actual problem, right, why is it hard going from a big fat Intel machine to a embedded device, heterogeneous supercomputer? If you look into the history of software development and hardware, you actually started, single application, single processor. Looks like a pretty easy problem, right? You press a button, your compiler, you generate code, you're done, right? If you look at the next generation of that, it already gets a little bit more difficult. You have, some kind of parallel application, right? Complicated dynamic applications, doing SLAM, doing perception, path planning, all those kind of algorithms. And they're going to run at some kind of, small supercomputer, heterogeneous multi-core. So heterogeneous meaning already different types of cores, right? Some ARMs, some DSPs, and so on. But now the problem even bigger, you saw the box earlier from Zeren, I guess. You had a lot of different algorithms, and they all will run on the same platform. Not on the same cluster maybe, but certainly all on the same platform, right? They're all going to talk to each other. They're all going to exchange data. They're all going to create contention on your supercomputer. And of course, that's going to be really, really hot, and you have a huge, huge power problem, right? So what we've built, and we started like 15 years ago, to us, one of the key things is software running on those chips, right? If you can optimize the software, suddenly you don't need such a big system burning all that power, but you can actually use different types of systems, right? So what we did, for a long time, we used compiler technology to actually automatically understand your code. We just look at your code. We know exactly which kind of platform you would need, right? We build a model of your application. Well, if you have a model of your application and you create that automatically, well, now I can also optimize that model, right? Find further parallelism, distribute it better, distribute it for performance, distribute it for power efficiency, right? average power at the end is a problem because that's creating your heat. So if I can distribute in a smarter way your software, you're going to save a lot of power, right? And then the third step, right? Well, if you have a huge, model of your application, you're not going to manually change your code again, right? So certainly there needs to be a third step, how you integrate that into existing toolings, because there are hundreds of different tools and workflows. So, with that concept of analyze, optimize, implement, how does that actually look like in a car, right? You're going to have a high-performance cluster. You're going to have an FPGA, probably getting your point cloud, doing sensor fusion. That sensor fusion from the FPGA is going to send data to your AI chip, right? Recognizing is it a bird or a person or a truck or whatever it's going to be. GPU at the same time is going to do a 360-degree surround view. Also, now trying to fuse that together with your AI chip, right? So that's just some example of what's going on in the supercomputer. And the key problem, and don't read all the details, key message here is the applications running on those different chips, they're actually very different types of application, right? You're going to have a CUDA stack, you're going to have a neural network, you're going to have dynamic C++ application, you have very static time slot based software development, which needs to be certified, right? Very different models of computation all have to run on the same chip. So what we're also building, this full system simulation. Show me your code, I can tell you exactly how it's going to behave on your system, optimizing for power, performance, and so on. So if any of that is of interest, headquarters in Cologne, we're around 50 people. You see a couple of logos of our customers. Yeah, that's basically it. If you want to see latest, greatest hardware like a Drive PX or something, feel free to come by in Cologne. Thank you.